OpenSpatial, a little bit about OpenSpatial. We provide geospatial engineering solutions, and we look at any kind of spatial data. We have focused on utilities, but really have a suite of software that we produce ourselves and with partners to build out your GIS and geospatial data. Our approach to this has been to use technologies that are already in place instead of building our own proprietary. So really what we do is build that solution that brings together CAD and GIS stuff. And that's what we focused on. We've been in business, actually I think I have a slide for that. We use open standards, no blobs, no proprietary APIs, none of that stuff that requires you have to absolutely have one of our products to get to your data. Data is data. Our philosophy is you should not have to go through some proprietary gateway or API to get to any information whatsoever. The other thing is we focus on producing tools where there's a single source of truth for your data in your organization, but also for sustainability, you need to have the folks that are responsible and understand that data, maintaining and updating it. Often in GIS, what happens is the maps get sent to GIS and some GIS person has to now interpret engineering or utilities or any of those things, become one of those sorts of experts, capture data, and that's fine. It usually works okay the first year or two, but then it doesn't get maintained because they're not on the hook. It's not their data. They're just doing it as a service. Sometimes that works just fine, but in general, it's better to have the people who are responsible for the data enabled to maintain it themselves. They'll do a better job. And so you kind of want that as an overall principle. We have 5 core software products. There's one called Munsis, and it is what I'll show you. I'll show you a few of these today. And these are the tools that we've developed for going from CAD to GIS. Munsis is an editing tool. It's an application that runs on top of AutoCAD and does some magic with the data in that it doesn't use, it stores the data in a single source of truth in a database and allows you still to use CAD but maintain GIS data. So GIS people like us because all the utility data is now available in GIS. CAD people like us because they can maintain their own data and build GIS data at the same time. We have a full web-based geospatial portal with an integration platform. So if you want to get going and up and running really quick and easy, our stuff is off-the-shelf applications that run and can be built out. We have a product called AC/DC. My Australian colleagues have developed this. And that's because they talk about as constructed. They don't talk about as built. So that's where the AC comes from. The DC is design certification. This is the future. This is kind of the equivalent of the BIM standard guidelines with data involved in it. What we do with this is on 2D plans, we have this product called AC/DC that allows you to get the designer, CAD draftsperson, to use a set standard that you define and validate that before they even submit the drawing to you. And when they validate it, then that data is push-button consumable in your systems, whether that's Esri or ours or whatever. And so think about this as this is where you want to be. 5, 10 years from now, or even a year from now, you want to have your standards, which are geospatial, attributed, and business rules in terms of snapping and joining and not connected or whatever, or has to have a valve on the end or things like that, all defined in here. I might show it to you. We tie in with work order management, and then I did a mobile thing this morning as well. So data collectors. About the company, started out in South Africa. Actually in 1994, I think I was still there, and I didn't even know about them. But the technology started there and has moved globally. I've been with OpenSpatial since 2005. I run the North American outfit based out of California. Our head office is in Australia. That's where all our programmers sit. And the original office in South Africa is still going strong. But enough of that. In terms of customers, cities and counties and campuses. So City and County of San Francisco, their full combined sewer storm network where not a drop of water gets into the ocean from any of the weird rainfalls that happen. They've been managing their stuff in our Munsis product since 2005 was my first sale on this technology, and they literally now have every last single thing captured on those systems throughout the city, and they push that data to 5 Esri SDE databases on a regular programmed automated basis. So anyway, a lot of counties. We manage probably worldwide. We've got about 6 million land parcels being managed with our system. I won't run through all of them. Some of these cities are small, some are large. We also have a lot of utility districts, airports. San Francisco International Airport use Munsys on all their underground utilities, and then the ones obviously you're interested in, Notre Dame, CU Boulder, USC, and Michigan State are capturing and or using all of our solutions using various mix of products, and I'll show you some of that. So today's focus, going from CAD to GIS. You actually have to step back. What it's really about is getting a structured, attributed data set in a location or in a technology that can be used by all of those that consume it. Back to that thing. What's the problem? Who you're trying to solve a problem for? How many of you still have a lot of your data in paper plans? Okay, it's a real problem. It's still there. And actually, all you want is to extract the current stuff that you really need and have access to the plan if you really need to get more detail. You don't want to go and get absolutely everything out of it. There's some places, map books, paper map books. This organization actually had 3 of these map books, and each tag page has changes on it like that one. Okay, that's a problem. Or you have CAD stuff like this. You have a system-wide base map or map for each utility, or even, and this is subdivision on campus, you'll have your capital improvement projects or whatever, where you have CAD data coming in at different scales, different places, coming from consultants, in-house, whatever it is, there's CAD stuff. So the trick is, well, how do you get an asset inventory for any of the utilities? How do you get it out of here and get it into a manageable form? Common CAD stuff. This is actual campus data, but things, CAD is great. You can draw anything you like. You can draw it really accurately, and it communicates a design intent. But it has challenges when you're trying to make GIS data. Challenges like the stuff is broken where there's line work. You could never out of this get what's the total length of lines by diameter. And then more importantly, you get to, well, what if this pipe breaks here? Where's it going to, where do I need to shut it off? Well, if this is your data, you're ready, because like that line is drawn just straight down there, there's a gap. This thing is not broken at the T's. It's not modeling ready, it's not attributed. It's a picture. And it may even be schematic, might not even be real world, so it's not even GPS. So these are challenges. The most important and really most challenging problem is attributes. Human brain is great. We can look at this and say 24-inch chilled water return supply. We can even go, hey, inverts, and that means northeast. It's this one, and it's this end of that one. Well, that doesn't gel in trying to get a computer model as to, well, where does this stormwater drain based on the design plans we have. How do you do that? Okay, I'll show you. Let's just look at this a little bit. If you have scanned plans, the first job is scan them, stick them in either document management or a folder structure. What we literally do with that is we take these things, the ones that have a plan view that you still want to get, go in. This is Munsys, by the way. I'll show you live, so I'm not going to give you all that. But it's pull-down menus that are way over and above everything you get in AutoCAD. But build on Autodesk functionality. If you know CAD, you can take an image and insert it into a drawing, and you can scale and rotate it, and there it is. And then you save your drawing, and if nobody knows that you've saved that drawing, no one else will ever know that you actually took the trouble and lined it up and everything else. They'll probably just do it again. And that's fine. So what we do is we actually have tools to capture, well, there's all the insert and georeference. So we've built it into automatically, and I just showed the points, georeference it, but then it's create the geoscan boundary. So you see that little blue box? That's the easy boundary. That just take the piece of paper, and I know the project plan is probably only half the piece of paper, and if you want to, you can draw a polygon there. But those polygons, when we use that function, we automatically create and extract from the image the path, the name, and then you can go in and add, well, what's the project number and what disciplines was it in? Some metadata like it was sewer or water or it was chilled water or whatever it is, and put it in there, and then save that little box as a GIS piece of data. What does that mean? If you do that on a bunch of plans, it means you can go anywhere on campus and say, what plans do we have on record right here? because a lot of folks will tie a plan to a discipline. Well, the thing is, these plans have a lot of information on them. This thing has stormwater, there's the sewer being pulled off, heads up, digitized, but there's storm, there's traffic, there's electrics, there's a lot of extra stuff. So are you really going to go and put that file name on every one of those utilities? Probably not. Just put it down as a box, and now you can do a point in Polygon. Hey, we have a GIS. If I'm at this point, show me any of the boxes that cover me, and I can list them and give you the file names. So that's what you can do. I mentioned that when I move on. So let's look at Munsis. Looks like CAD. Actually, it's not. Here's a listing of all of those things that you see right there, and here's the columns. So let's actually take a little look at that live. So I've got a live project that I have been working on, and so we can show you. So Munsis, oh, don't worry about my desktop. There we go. Good. All right. So what Munsis is an application that sits on top of AutoCAD. So if you know AutoCAD, you know 80% of this product. Training is a matter of days, okay? Because all you got to learn is what are the feature classes and what's the concepts behind it. I show you a blank canvas, but I'm going to come back to that. Let's say you have a drawing like this one. So first thing, normally your CAD drawings, you'll see these ones are either twisted or aligned. Well, that means I took the CAD drawing and I put it in real world coordinates, and I got it. So twisted means I just, this thing was drawn to fit on the piece of paper, and now we've put it in real world, so it's right there. And you can actually go in and check that the coordinates you see here are the ones you see down there. You can see it's got a coordinate system assigned. So there's a bunch of steps you need to go there. But here's the campus CAD map, right? And it's the survey version thereof. So this is just CAD. If I click on that thing, it's a block. Okay? It's a drainage inlet structure. And so you go. And this is a 4-inch line. Actually, it's 2 lines. It's that one and this one. There. And it's a piece of text. So how do you get that to be a real piece of data? Okay? It's located pretty good. If I turn on the image just to do a sanity check, no pun intended, and so if you turn that on, and if I'm on a network, eventually I'll get a picture on I'm on a hotspot. So there you go. Okay? So now already I've got the CAD located. You kind of check that stuff, and you go in and do that. I'm going to turn that off because it's really going to make it pretty slow. And if you draw this out, this is CAD. So what do we do with this? I'll take this CAD drawing and I run an analysis on it. I'll come in here and let's go and open recents. There we go. I took that CAD drawing and ripped through it with a little analysis. Actually, they have 2 CAD drawings. The one is the campus map and the other one's the utility map. The campus map has some utilities. They're being surveyed, so they're spatially accurate, but they're incomplete because the surveyor really doesn't know where the pipe actually goes. He just knows that from this manhole there's a pipe. Where does it go? Not so much. The utility is the old schematic that knows where the pipes go. They're just not located very well because they were drawn in CAD over the years, and so you go. And that's very typical what you get. Actually, this CAD data, certainly on this map here, is pretty good. It's laid out. So we can pull out the layers. So if you go to every layer, so that's a summary. Each layer is this is the layer name, and this is whether it has data on it or not, right? So then if you go to each layer, you can say, let's look at, say, trees. I'll scroll down a little bit. So on the tree layer, we had a bunch of text, bunch of circles, ellipses, P-lines, text, a bunch of blocks. So there's the trees, and actually there's the count of the trees. So that's probably where most of the data is. And then there's some lines and arcs and polylines and stuff like that. So how do you get this CAD data into it? We also look at the blocks themselves, what layers they're on. So if I go to the tree block, let's see. Yeah, here we go. Here we can see that it's pretty good. I mean, that's pretty good. That means the tree block is, this tree block, that one, has all of them but one on the one layer. That's pretty good. Normally they're on all sorts of layers. But there is a red bud that escaped onto the elevations layer. And that's another thing that happens on CAD. The stuff just goes everywhere. So this is kind of how with signs, there's this concept: is it a sign, a traffic, or a sign? And so with an SMH, there's some on that layer and some on this layer, and stuff like that. So you can go in and do this sort of analysis. So we've been doing this 18 years. So obviously, I have great routines for ripping through drawings and finding out what's there. The other thing you want to do is come in here and say, okay, now let's do the rel trick. So what I would do in Munsys, I can come in, and if this is the other CAD problem, right? It used to be a tree block. Now it's a circle. Somebody exploded it. Happens all the time, everywhere. So that's the other thing you got to sort out. So if we come in here, a lot of those guys are there, whereas these have not been exploded. So if I go to this guy, it's a block. Well, wouldn't you know, it's a tree 1 block, whereas it should be a 12-inch cypress with a block that looks like a tree. Okay? So that's kind of the difference. And that's a piece of text next to it. And then if you go to some of those have been exploded, so I've got millions of itty-bitty little lines all over and a circle in the middle and a piece of text. So those are all things you got to deal with. Whereas like the palms, they're pretty good. They're just it's actually a palm block, and I can see it looks great, so that's fine. So what we do in Munsys here is this trick between GIS and CAD. So Munsys allows you to connect with the database. So one of the first things I did was connect to the database, and I'll just do it again just so you can see. So this is a multi-user editing tool where you can have multiple people editing. It has full record locking. Each person can be editing different things at different time. And so I can come in here now and literally go in and convert these things, if they're convertible, into intelligent database objects. So what's going on in the back end? In the back end, I've just connected to a schema of data. And that means, the schema means a set of tables in a database with all of their relationships and everything else. So if I look at the spatial tables, what I've done is I actually have a trees table. There it is. And it has these columns in it. And what I'm going to do is take the CAD stuff, stick it in that table. And then I'll be able to do stuff with it. So the way to do that, in Munsys there's different applications off the shelf. So sewer and drainage, understand the difference between culverts and pipes in drainage, and understand all the invert elevations, and have tools for you automatically to update those and build them out. Very, very powerful stuff. And to check that you've actually, captured everything. I'll show you a couple of those. Let's finish up with trees quickly. So the Spatial Data Manager, that's our generic GIS. You can create any point line polygon you like and add any kind of attribute to it that you like. So let's go to these trees and see if we can convert some of them. So one of the simplest way is just to go capture, convert objects to spatial objects. And so if I come in here and I go to trees, at this point I can just get the layer they're on. That's the simplest way. But that's going to miss out on a bit of information. That block actually does have information. 70% of them, the block told me what kind of thing it was. So I want that. So in Munsys we've developed, so all these menus, by the way, are the Munsys menus. There's some CAD stuff like drawing over here. But if I come in here and I use the mun convert, this is one of the bits of magic. This is a Munsys thing that exposes all of the attributes of the CAD data, and so you build it out. So step one is get stuff out of CAD into a database. Once you have it there in Munsys, now you can still use CAD to continue maintaining it, but the data in the database is GIS data. It can be used by GIS. So that's bridging the gap between those. Right, this tool, mun convert. You can go into, this shows you all the columns on that particular feature class. So I can go in on the symbol name and say, let's assign from the CAD drawing, I want the block.name. So this is all CAD properties. So I can go to block name here and say, okay, that's going to go into the symbol name. And actually I want the blocks because somebody took a lot of trouble laying them out, getting their size and scale. So this is symbol scale, so I get block scale there. And I want the angle, so I just pull that out of here, block rotation. So I'm building this out. I can put anything else in here I want, like I can assign a constant value, and I'm just going to put in that I'm messing with it, so I can come back and track it. And there's all sorts of stuff. If I wanted to, I could do certain trees at a time and whatever, and I could save this profile and use it later. So if you actually have the same drawings over and over, you can actually define these data loading profiles. So I come in here now, and I can go in and select the trees I want to do. So I could just drag a box. Let's do all of those guys, and set to not do an additive selection. So let's take these guys. So I'll just do a few, right? And we can pull them in maybe a palm or two. So I could drag the whole lot. I could have isolated the layers, so I just had those blocks, and then drag a window and grab the whole lot, get the picture, right? So I put those into Munsys, and it said it's converted 14 of that, and there's 4 warnings. When you get a warning, it actually puts a circle there, and it'll tell me, wait a minute, the block name wasn't defined, or anything like that, it'll tell you. So you do that process, and then what we've done is we actually go and look for text. If you have text near the object, we have rules where I can go and search for this text string within a distance, and then I'll find the exact position and automatically put it on the object. So let's go back to this. If I come here, I can run. So that was how you convert it, and I'll post that to the database. Now if you want to get the data back out the database, I can go here and say, well, let's show me the trees. And that whole area is in all of campus. So actually I'm going to just I can set a filter for any specific area or zone. I'm just going to do a box for everything and go run that. And so now you're going to have all those trees come in. They've been converted. So now you see the same thing, right? Although, as I select on it, you'll see the text comes with it. And now it's in the database. It has the block name, pulls over the scale it had, and we literally threw into the tag value. We use tag value as a common, put text in there, the text that went with it. So that's now GIS data. And you can see this guy is a 24-inch, well, it actually is not. It's just a tree trunk 1. So the symbol name has not been processed yet. So this is work in progress, and that's what you do. So let's look a little deeper. So tech folks in the room. If I go here, there's the trees table. So our database is using Oracle. We use the geometry column in Oracle. Well-defined data sets, completely open tables. This is the free thing for listing database info. Here's those columns on the tree table for the data we're just looking at. Okay, and the tag values there, and the position, the tag X and Y is the position of where the text is, and there's the geometry column. Okay, so what I've done is when we converted the data, all we could do is get this text string right off the drawing. And so the same will be for inverts and top of curve and all that other stuff. And so what I've done there is to pull that out and put it into the tree type and size columns. How did I do that? Well, once I put this column in the database, I can run a simple bit of SQL to split that out into 6-inch, holly, and put them in different columns. For the rel techies, here's what it looks like. I just ran an update statement to update this column here, and I've extracted out of it just the numerics out of that tag value column. So with those simple bits of SQL and that simple conversion, I now actually have the data for the trees. And more than that, you can run a simple piece of a simple one of these. It doesn't look like I have it open. Let's go find it. Well, that's the results, and go here. Just go find that project quickly. So I can come in and run a tree report. It's actually really just one line of SQL that's setting out a CSV. It's there, and you can put, these are just SQL statements. You could be running it out of an app, or click a button and it runs. You can put it on the Munsys menu, run it from there. I'm just showing you because it's a little more technical, kind of gives you an idea. Here's the actual data. This is where you go. If I run that, it'll create a CSV called tree count summary, and I open that in Excel, and there it is. So going from CAD, I now have a report. Yes, there's work to do. the smart people in the room are going to pick it up real quick, because 10-inch Cypress is actually there twice. Any ideas why? Because I didn't do the SQL properly. No, there's spaces in the names, and they just need to run a trim. It's in the database. Beautiful thing. I can run trim and do it just like that. And so that's what you work through it. You'll look for funny values. You'll look for misspellings. But here is a count of trees by diameter, etc. So you can look at what's unknown. You can nail them down. So I can come in on the map and say, okay, it's GIS. Show me all those trees with an unknown type. So if I can come to the tree query here, and on trees I can say, put a filter on it. So I can come in here and say, okay, well, where the tree type is equal to, and get the values, pick whatever you want. Let's say I'll just say unknown. And because I'm a little more database savvy, I'll put a wild character and I'll get all the unknowns. So I'll say like, and I'll say, oh, do you see the space in front of that thing? Good idea to use like, so you get rid of the spaces. And we'll just use anything that contains unknown. Okay, rerun that query here. And now on the screen, there are all your tree types that are unknown. And there's 83 of them. I can color them up and off we go. I've just gone from CAD to GIS. Boom, right there. Okay? Let's show you a little more difficult. That's just point features. Let's get rid of that. Let's look at stormwater. So these guys have this thing that's got the stormwater from the survey. And so the surveyor went here and says there's a pipe going there, there, and there, but they really don't know where this pipe goes. Does it join with that one? Don't know. But they also have this other drawing here, which is the old utilities map, and this one is really not to scale. It was architectural, and it was at kind of 0, so we've moved it and fixed it, and we're literally going to stretch it as we go in each section so that we can get it as accurate as possible. But it looks like this. All right? So it's more schematic. You'll see there's a drainage pipe that actually links all of those. So probably it drains from there and goes to the left. And probably, well, it's drawn a little schematic. It probably goes through that manhole and through that one. And actually, it's probably not even curved at all. It's probably straight, manhole to manhole to manhole. It's a drainage pipe, right? So what I can do is go to this map and convert these to Muncis using the MunConvert routines I just showed you. For now, I'm going to ignore the invert elevations because there's some really useful data right there, and convert those into Muncis. So let's go in here and pull in the Muncis data. So what I'm going to do is set my area of interest right here, just so we don't query in the whole world while we're there. Go to this. Notice I don't open a CAD drawing. I actually pull in data from the database. So I can go to drainage and pull in the stormwater. So we've processed some of these, those ones that you've seen there, stormwater nodes and whatever, right? So there's the survey stuff and there's the other stuff. So I can see how they align. And clearly I can say, well, wait a minute. This pipe here and that pipe, between these two, those should be joined. So I'm going to lock that guy. Okay. It doesn't allow me. Obviously, I've got a bunch of things locked already. I was messing with this. So let's just unlock these quickly. And erase some objects on the... I'm just going to query these two things in again, just so I get everything in sync. So we'll run that query again. Go. So now we can go lock that object. So I'm going to say, let's take this 8-inch pipe here and put it this way. So this is where the CAD GIS thing is really great, because the CAD guy, they know how to deal with all these snaps and pull it there and pop it right on and snap it, right? So I've actually stretched that pipe like that. It should be there. The problem is, what about directionality? So I'll change to the drainage application. All that does is roll my top menu. But now I have a top menu that's intelligent for drainage. So when I go now, I can see I'm dealing with drainage pipes, channels and culverts. I'm dealing with inlets and manholes and stuff like that. But let's go in here and actually just show the flow direction. So this will show the original direction the CAD was drawn in. Okay? So if I don't lose my mouse, yeah, there we go. I'm going to drag it over there and draw it on. So it puts little arrows down for me to look at. So I can see, well, sorry, I know the other guy, this thing's going in that direction. So we can go and switch them. So change the flow direction. That one's wrong. This one's wrong. Where's that one? That is wrong. That should be flipped. That's coming down. That's good. Oh, that little guy's wrong. And flip him. Done. Okay? So that's step one. So let's go in and actually check those. So what you do before you post to the database, you have to validate these objects. So there's a validate little thing here. We select the objects and it's going to shout at me. So it looks, this is the whole data, this is how you get good data. It's just checked. Is it inside your database? Are there drainage nodes that are not connected? Are there pipes that don't have the attributes? It's checked all of those things. This is what I show you in training, is how to deal with this. Actually, you can hit errors and it'll put a little circle next to where those are. And you can zoom to them. Okay? So those red circles will tell you the problems. So here's a drainage pipe, this one. If I move my mouse, it says, look, there's got to be something on the end of the storm drain. If you don't know what it is, put a junction there, for heaven's sake, or something. But it's not going to pass into any modeling program. It's just not going to fly, because drainage has to have a start and end on it. It'll come in and say, oh, you see this little guy, this red one. If I click on it, I know exactly where it is, because it's the base of that. That's that pipe that goes there. So that's easy, because I added a new pipe. This one is messed up, so what I'm going to do is go and delete that object, right? So the delete is actually doing a database delete. So you can select and hit erase on the drawing, still in the database, because the database is the data of record. So I put that, now it's flagged for delete. And the next time I post, that's gone. So what you literally do is, as you fix these, you go and put them down. So you can come in and say, capture endpoint node. Let's just put a drop inlet on the end of this pipe. If I select not a drainage pipe, it's something else, it will not allow me to do that. Because it knows on the menu, it's expecting it'll put it down. Don't worry about the scale, it'll figure that out. And so you go. And it would show you, if I pulled this off and it wasn't snapped, it would show me. Or if it was if you were in water and it was a reducer and there were two pipes coming into the reducer, it would say too many pipes on the node. Business intelligence within the apps themselves as an off-the-shelf application. So I'm just going to take that stuff, run the integrity check again, ignore the errors. It also checks for a network integrity. So if I do that now, what that's going to do is build out the start and end nodes and build out the topology. So this thing actually knows this pipe will have entered into it the start and end node. I'll post that to the database. It's either one to be deleted. You can be using a drawing that's in a different coordinate system than your database, and post that to the database. So it's posted them, we're done. So now if I go to a blank drawing and I go to that area and I query back that information, I don't think where's that query? I got stormwater pipes. Yep. So there it is. All put in. It's done. I can throw away that other CAD drawing. It's in here. And if I go and look at these guys, you'll see it's built put that in there. It's actually picked up the ground levels from the depths on the manholes and applied them on the pipe. So this pipe, obviously the one manhole had information on it on the end of that pipe, so it's already inserted them on here. So we start building out that whole relationship. So that's kind of just to show you, give you an idea on how to go through a CAD drawing, pull this stuff up, and then have this wonderful editing tool to be able to do it. If you want to edit something, you just go change edit attributes, select the guys you want, say I want to edit these nodes, just to show you this is what the editing dialog looks like. And you can come in. So this is CAD on steroids, because now you don't have this in AutoCAD, no way. So I can come in, either do one by one and zoom to the little guys, so auto zoom as I select it, and step my way through it and go and edit them, and go change stuff, or I could do a global in here and just put the usual problem there and post that. So the moment you change something, it flags them with a modified, and then you can go push it into the database. When I try and push it into this database, it's going to tell me, hey, you didn't validate, and currently I have validation switched on. That is a setting you set up to say, no, those columns are mandatory. You have to have diameter on a pipe, others ain't coming in. Stuff like that. Very important, really helps you. So that's Munces. Any questions on Munces before I move along?
I have one.
Yes.
How does it deal with dynamic blocks?
With dynamic blocks. For dynamic blocks, what we're doing is basically you're taking that data and you're splitting it out. Well, first of all, the block itself carries the primary information, and then the dynamic part is when you want certain bits of stuff displayed and not displayed.
Or it can be completely different.
Yeah. And so we'll actually split it out into different zoom scales and store the information separately. So dynamic blocks actually create a problem because they're contained within the block itself and nobody else can get to it.
Multiple.
Yeah. And so you actually have to go and pull out, well, what's the intent of it? So first of all, it has the primary asset information. That's easy. It's then the representation. So for that, we actually can have multiple symbol names and then different bits of related text to go with it. Actually, I didn't show you another one in Munces. It's a good question. The other thing that is a challenge, let's go back to that where I was. We'll zoom to that little spot in here and query in a few things. Pipes, notes, go. The other thing is how to get the data that's in text onto objects themselves. And so on that, you can see this is pretty good. If I click on that node there, it doesn't have yet, it doesn't have the depth, it doesn't have any size or ground level or anything. So what we do there is I have on the menu, I put on the menu various routines. I'll just show you one here quickly. Processing. Let's do util. So if, say I want to get the ground levels here. Because we're in AutoCAD, I can use the full AutoCAD functionality and our database, pushing stuff into the database. So what I'm doing is running essentially what I put on the menu. And it says, show me the source object. So I want that manhole, and I want this as the top of cost is what the TC is. And I've literally now tagged that thing with this. And so I can go and repeat that everywhere. I can say, okay, that's the text. So this goes a whole lot quicker than typing it in by hand. And when at the end of the day, I've also got the position of where that text was, so that when I bring it back, when it's actually in the GIS, it'll appear in the same position, but it goes with that. It's now an attribute of the object. And so that's huge, because the layout of all of these is, there's a lot of time and effort. So just to show you, that's kind of how we do that. I do have automated routines, and I could use it in this case, and I haven't yet because of justification problems on the text itself. We have routines that look at proximity. So if you've got a manhole, I can say, okay, if there's a text that starts with TC within 10 feet of this manhole, then accept that it works on that manhole and stick it on. The problem is you get these little muckers here that is left justified over there. So it's not within that distance, and so then you end up going. So you have to look at it. Sometimes it's better to automate all of that and then go and fix the anomalies. Sometimes it's better to just build it out by hand. Because we're having to look at these pipes from two different drawings at the same time to get that information in. I'm like, let's just build it out. With this routine, it goes pretty quick. You can explicitly say, yes, this is it. The other thing is the inverts. You see, you have to know that that goes with this and this goes with that. And it looks fine here. That one's easy, but you'll get other ones where it's not as clear because there's another one next to it. So does this text is justified to the end of that line? Does it go there or to the next one? Stuff like that. So these, with the directionality, you want to pretty much have someone explicitly know the direction and then go and put in the inverts. Otherwise, it becomes a little sort of mouse on a treadmill, because now you switch direction, you've also got to switch all of the start and ends. And we got routines to do that, but you just don't want to make work for yourself. There's enough work. All right, so that's it. Going from there to there, where we've got this stuff now pulled in. So if I come in here, and set my GSC wide open over here, we can come in and just query in pretty much a whole bunch of stuff. So say you do like buildings, polygons are also fun. We got nodes, do trees, drainage, sewer. So you got all of this stuff built out. Campus furniture, so bike racks, CATV, go. So when I run these queries, it's literally going to the database, and each one of those is running, and probably I have that filter still applied on the tree guy there, that asterisk, so it's still got that filter applied. So I could clear that, or I could save that query for other reasons. Where are we? Reset, yeah. But now we're looking at a campus map that's more attributed, got diameter on the pipes already, you can see all of those. So that, you change the diameter, that label will change automatically. Stuff like that, you can see the buildings are building in there, and everything's nicely aligned, and you start building out a data set. These lines are the crown lines for the trees, drip lines, because it's kind of wet. And little trick there, don't store the lines as the tree. If it's a block, you need a block. So we've got the tree stump. Actually, if I run the trees now that I've taken that query off, you'd see them there. So there's the actual stump of the tree, and you can see the size. So that's a 48-inch oak, and there it is. Okay? Right, moving on. So that's what I mean by data here that is in structured, it's complete. Oh, there's directionalities on there, so we can do trace up and down, knows the difference between a water and a sewer and all of that. So I just showed you all of this live, so I'm going to whip right through it.
So I have one question.
One question, yes.
So that drawing is also an Esri GIS, for example? Because
No.
I know it's a GIS because we attach and it tells you all the data, but it's also an Esri GIS?
No. Good question. There's a slide that'll help with that. Everything in dark blue here is our products. So in Munsis, I was sitting in this application on top of AutoCAD map, I don't know, 2015, 16, 17, and I was using these applications for drainage or spatial data manager. I was taking CAD data out of there, putting it into an off-the-shelf data model here that runs on Oracle. So those spatial tables are Oracle tables. They have an SRID, they're indexed and everything else in there. If you wanted to look at that data in Esri, you would connect it. I put it as another GIS. Any GIS you can connect to this information. We use OpenGIS Consortium standards. When you talk about open data, you've got to be really careful. Open data doesn't mean, oh, we have a way to give it so everyone else can see it, but not edit it. For me, it really means it's completely available without us being there, and it's actually the source data. So, little thing. I showed you the Munsis Management Console. That's just an app so that you don't have to be an Oracle whiz. I mean, we literally have folks where the CAD guys are running the GIS and doing the database management of adding columns and pick lists and all of that stuff because it's off the shelf and out the box. The second part of all of this is our other product, Enlighten. If you look at distribution, you can see that same data in InfraWorks or on a web browser or on a mobile device. Okay, and so that's kind of the layout. If you want to add anything, so someone asks, so what about SAP? What about Maxima? That's a database-to-database connection over here. I know life isn't as easy as that because you want to say, well, if we add something in the GIS, our GIS, you also want it to be added into the database at the same time. But by taking this CAD product, the CAD data, and making it into a database, we've solved half that problem. Now it's a whole lot easier because all our reporting, we've got a single source of truth. We can have capital improvements derived from here, and we can tie in with these things. So if you've got room spaces, so if you're using like Famous or Ames, we'll take those room spaces, and just like I did with the imagery, I work out where the floor space drawing, that's at 0, 0, where's it in the real world? What's the scale and rotate? I store that information, and then I give you a simple function where you push the button and it will take in this drawing, look at the drawing name, so it's got building number, floor, whatever. It knows where the scale and rotate is, and we have predefined to pull out whatever line work you need, what polygons you need to get a room polygon, for example, that is got the region, floor, room number. Already there's a polygon, and then from there, all you have in here is the polygon. The rest of it is in whatever system in the database where they're actually maintaining those attributes, because you don't want to duplicate data. You do want to tie in with that. So that's the sort of stuff. Okay, AC/DC. Don't think I'm going to have time to show you this one, but this is a tool for allowing you to bridge that gap. I'll spend one slide on it, this slide right here. So in AC/DC, we're trying to go from CAD plans to GIS without having Munces per se. Munces is if you're really doing that editing. If you're not, and you just want people to give you CAD in a format where you can check it, consume it, and put it right in, that's fine. Use AC/DC. Here's the magic. Configure it. The people making the CAD never look at it. This is where you set up your CAD template, the rules. And I really mean rules. I mean a manhole has to have a depth, and it's this block, and it has to have, you can't have a manhole unless there's a sewer pipe connected to it. So we're actually checking linear, touching, all of that can be set up. And you set that up, and you set up the data mapping. You say, oh, and that goes to this feature class, and these attributes go to these columns, and these are the pick lists within this data that allows for a valid piece of data for whatever you're looking at, like whatever diameters and things you have. So AC/DC, the user can go to the validator, which is in the cloud, so they can go to a simple portal, just a web page. If they've got to log in, they can submit their CAD drawing. And it will check whether it passes or fails. If it fails, we'll create a DWG with the same circles I showed you in Munces, showing you, here's the error, this is the error, and give you a list of the errors. And you, if you're on the portal, will get a little notification. You'll be able to see the history. Oh, they submitted this drawing. There was 2 things wrong. And so we go, okay? And that's how AC/DC works. There's a whole lot of magic once you've got it passed. So here's the big deal with this. We're taking the burden of proof. In other words, we're taking the responsibility for drawing it right in the first place and making them do it. Before they even give it to you, it has to pass. Okay? In other words, you're getting the designer, the person who creates it, to fill out all of those attributes. You're giving them the template, and in the template we will add in all of the attribute definitions that are needed within any given thing. So you make it standard for them, and when they bid for the job, you say, yep, here's our standards, here's the template, here's how you check it. And we won't accept it unless it is checked. And that's how you can get that stuff in there. So we literally are taking somewhere where a CAD plan check can take anywhere between 1 day and a week, depending on how much stuff you're going to run through. And also the people that check plans are really excellent people, and you want that expertise to be applied to the right place. You don't want those people to be looking at, oh, well, you used the wrong line style. Or, no, this block is not the right, this is not our block. The reason they were checking line styles and blocks is because those were the things carrying the attributes that they wanted. Okay? So nothing about the people. It's just now you can look at it and say, okay, the plan check, it passed the validation. So I know categorically that it's filled out all the stuff. They're all on the right layers. That's everything that I need is there. All I'm checking now is design intent and those sorts of things. Now that's much more valuable. And so you can literally change the organization. So we check things. All the geometry attribute will actually also solve some of those CAD problems, because when they draw a pipe in CAD and then they stick valves down, they go ting, 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 valve, 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 and it's one line. And they'll put down the diameter of that line next to it once for the whole line. That's fine. So we actually solve that. We'll actually take that, and on the valves we'll have a rule. A valve has to be on a pipe. We also have another rule. If the valve's on a pipe and the pipe's not broken, we'll break it and we'll carry the attributes of the line onto each segment of the line. So we'll actually pre-process that thing when we're doing validation. And then, and the way we do that is in CAD, it's easy to put attributes on blocks. The CAD drawing's clean. Very difficult on lines and polygons. Polygons, it's okay, you put a piece of text inside it and people can use that. But on lines and polygons, it's a little more difficult. So what we do is we have in the template that you put a block at the midpoint of the line. They have to snap it to the midpoint of the line. We'll check that they've snapped it. And on the block, we'll carry all the attributes you want for that pipe, like diameter material. We'll give them a block where they can just drag the text and lay it out like they want, but it all goes with that block. And that way, when we do a validation, we actually look at that block, we find it on the midpoint of the line, we break the line where it needs to be, and we put all that data that was in the block as object data on the line. GIS people are really happy because now they got if they just get the CAD drawing like that, they've got a CAD drawing with object data on a line, pull it right in, no big deal. Okay? Or you could use our product to push it right out into your GIS directly. So yes, AC/DC will push stuff into feature classes within Esri SDE databases. You predefine it, set it all up, works great. I could show you in real world how it does, but you see stuff like this. This is Australia, a little metric, but that's an I instead of a 1, and so it's in invalid numeric value, little things. You see the circle actually gives you the error. So you change it from a whole lot of steps to a whole less steps. All right. It's on a portal. If you go to asconstructed.com, you'll see City of Wellington been running this. They do they're now doing every new subdivision stuff gets pushed through that system. There's another executive thing in there, but you sign in, you submit, and you validate it. Let me go and jump right down to how to get from CAD to GIS and more. So here's a few examples. I showed you that picture. This data is in our Enlighten product, the web-based portal. And in the web-based portal, it includes the ability to connect to other databases. So what this is a water network. And these guys, as you move your mouse over any one of these water service connections, you get a chart of the last 3 reads. That's coming out of a different database. Okay? And that's built-in integration within the platform, within the web-based tool. So if you move it around, you can do that. The moment I showed them that, they said, well, can you show me the gross water users? And I said, yeah, of course. So these are the yellow ones are 4 times the average of the last 2 months increase in water consumption. So there you go. So just to show you, it's dynamic. You can tie anything in on there. Here's another one. In that Munsis product, if you built out the connected network, you can come into Enlighten and Munsis and you can click on the pipe and say, hey, pipe breaks here, what does it impact? It'll tell you, hey, you've got to shut these valves, and then these, in this case, parcels on campus, it's actually buildings, will have no water. You like that? Okay. And here's a report. You can get a listing of all of them, and off you go. And you can trace right through. So say that valve is stuck, you can select it, and it will run the thing again and do that right on a browser. So anybody. And that browser is web-enabled and touch-enabled and GPS-enabled. So if I run it in Chrome on here, I can hit, say, where am I? And as long as I'm on a web connection, I have this information, my full GIS drill down right there. And you can get reports. Here's a project that we did. So here's the campus. You've probably seen this. And I've put these as slides because I'm actually on a hotspot right here. It's really, the connection's not good. But yeah, campus. Gross it out, turn on all the utilities. So this is an Enlighten product, but all of this stuff has been edited in Munsis that you've seen. So as you move around, let's page up a little. This is probably an older screenshot, but in here you've set up the categories and legends. The Enlighten framework gives you full control on users, who can see what, who can change what, can they do redlining, all of that stuff. You just set up the user admin for that. You can set up things like tooltips. That's pulling dynamic data out as you move around. Here's the ground panels with all the ground treatments. Here is the buildings and tying in with project management. Let me page up, that's gone too fast. So these guys can actually draw outside projects. They redline. It's right here. This will be like the project managers. They can redline on the browser, and then it will tie in to the project management data, which will put in. So as long as they put in like that number 78, that number is, all we need is the polygon with 78. That's all that's put in. And they do it in the browser. They don't need Munsis to do it in the browser. And they can then control whether it's visible or not visible, or whether it's been displayed by date. So a lot of these projects you can see year to date or active or within the next 90 days and stuff like that. So there's a real example. You can select things and get reports on them. Here's a drill down report. You can have hyperlinks and tie with other information. Right, I'm running out of time. You see the little dots? Well, that's all the Munsis data. You just saw it on the web, edited in Munsis. We got storm, we got sewer, we got water, there's natural gas, and this is the data being shown in InfraWorks. So if you were here for the workshop earlier at the beginning of the week, you can set InfraWorks to point directly at that Oracle spatial table as a data source, and it'll load it up. So what you're seeing is there. These trees are actually GPS. So we've got evergreen and deciduous, and so the height of the trees is being read out the database and scaled inside of the model. And so you can actually see that information right there. If I back off the image, you start seeing the stuff. Here's the tunnels, access tunnels underneath, and all that stuff. You can zoom around. You go underneath, pick up a pretty interesting intersection point there. It's InfraWorks, so now we can have the Munsis data. So this would be gas, storm, water, sewer, new building, Revit model. So you can start playing the futures and you can look at where existings are and all of that stuff tied in there. So what I've tried to show you is from CAD, actually paper, to CAD, GIS, and a bunch more things. Questions?
So how long does it take to convert one complex CAD?
Question is, how long does it take to convert a complex CAD drawing?
Yeah. Is it pretty cumbersome?
No, this is about the fastest you're going to do it. No, we're not. We're converting in batches. You set up the rules, you select them all, you do them. Done. Like all the sewer and drainage nodes, you do that in 2 minutes. Just set up the profile, you do it. The problem becomes where you have to hand go through the thing and say, well, wait a minute, that wasn't a block anymore, it was a circle, and so now I have a little thing that just says, okay, put one of those down there, delete the circle. So that is actually, and then the other one is like, if you're running through and joining those pipes, that's a pain. If the CAD drawing's clean, it goes real quick. If the CAD drawing has data in it, our stuff is exceedingly valuable because I'll pull in all the object data, any of the CAD properties, load those in. So how long does it take? Well, it depends. What I normally do on a project is I say, give me your CAD drawing, I'll look at it, and I'll tell you, okay, X number of days. These attributes, done. Okay. Question at the back, red shirt.
Oh, I was going to say, too, if you don't mind me saying, we use Munsis, and I've had projects of similar size, like go anywhere from a day to a week. It just depends how dirty the files were when we got them. And if you have to go to
Make no mistake, it's work. Converting CAD data is work, and it depends on how good or how bad the data is. But with these tools, you know that as you're cleaning up this drawing, you're actually creating an asset inventory that's in check, that it's got integrity, and so you really are moving forward. Whereas if you're just cleaning up a CAD drawing for cleaning up a CAD drawing's sake, you're kind of treading that treadmill. It really doesn't help that much. I mean, it's a start. Questions? Yes, Mohammed.
Practical to add other objects like, let's say, buildings, houses, streets, sidewalks, and that's it?
Whatever you want to maintain. I mean, if you look at like Boulder, they've got all of that stuff in there, but for the buildings, they're just doing the building footprints, and then the floor plans are coming straight out of the space management system, and the building information is coming from the building information system, but the outline is on the map. So as you move over the map, it gives you the data out of the other system. So you just have to decide. I mean, I'm not saying that Munsis will do every bit of data for everybody, but it's exceedingly well suited for the CAD data that you got.
Another question about topography. How does it react to the topography of the area?
To
Let's say
topography?
if you have some hills, some valleys.
I'm just storing data, so data's data, I don't care. I'll store in any attributes you want. The topography, if you're using Civil 3D or Map 3D, you can pull in point cloud, you can pull in DTMs, all of that stuff. It's the same, it's CAD. We have routines that we use often. I didn't show you that one, but a lot of them where we were getting the elevations right off of the DTM and putting that on the Munsis data automatically, so you pull that in. Sure. A lot of the water utilities, or water, they just assume everything's on the ground or 3 foot below, and we get the elevation, and they need the elevations because then you can calculate expected pressure if you have where the tanks are and what the head is for that zone. Anyway, digress. There was one at the back, sorry.
Is there any limitations with pushing to an SDE database?
Yes. So the data here is not in SDE at all. what you want to do, the various ways to connect Munsys with SDE is obviously we can output shape files or any other file format, and you can load it into SDE. Sometimes people do that, and in fact in Munsys we have Munsys export where you can actually set up the profile, much like FME or any of those ETLs, where you can set up the batch of creating files and let it automatically run on a scheduler, and it's hands off and it just replaces files. You can do that. Not the ideal way, but it actually ends up being a fairly definable practice, particularly like some cities, large cities. I mentioned one that's been a customer for a long time. They have 6 SDE databases and they use Munsys in one department, and they actually want a physical handoff of the file. So that actually means it is a pretty good way of doing it, because then they can say, no, you got that file on that date, it's the right one, and they're distributing it nightly to 6 different places. What you can do is, if you have the data interoperability extension on Esri, you can then connect to an Oracle spatial table with that. So all you do then is you go into our catalog, you add that as a layer, as a data connection, and then it's a layer that you can view read-only in our catalog. The reason is there's a whole, you could talk to me afterwards on it, but Oracle, the standard Oracle tables create their own spatial indexes using the OGC formats. Esri does a different kind of indexing and maintains a different unique indexing both spatially and at unique record-wise within the database. So they always apply that, which is why when you're looking at an SDE database, it doesn't run vanilla Oracle. It runs SDE within whatever other database. So it's a blob within the database. So to get to SDE data, you have to go through their API in their standards. To connect to our stuff, just use the data interop, because that's the way they can connect to any open source data. If you were using like QGIS, anyone in here use QGIS, by the way? Okay? In the last few years, it's added a huge amount of functionality. It's a desktop GIS, it's open source, it's free, it's GIS stuff. And so a lot of our places, folks use that as their analytic tool. So if they want a heat map, or they want to go and do, just take a shape file and look how that, or take some other data and look how that compares to their enterprise data, they just pull that in there and work with it. Or if they want to theme up the things nice and easily and they don't want to use an AutoCAD license, hey, just use QGIS. It, for example, connects right to these Oracle layers, built in, off the shelf, just set the data connection, off you go. All right, but it's a good question, and that is the reality, is how do you link them? So you can link live through our catalog with data interop from Esri. Last question, I believe. And then we'll be done. Okay, time's up. Thank you very much.